Today, we will be showing you how we figured out the following physics concepts: forces, kinematics, energy, and impulse and momentum.
First, we had to find the FW of the water gun filled with water. The way we did this was by placing the gun on the digital scale. Since the scale is measured in grams, we had to convert to kg to get the mass. Once we found the mass, we were able to find the FW. Next, we found the initial velocity and acceleration using the kinematic equations. In order to solve for them, we needed to get the distance of the water and the time it took for it to reach the max distance.
I was used as the reference point for the water's distance. We used a tape measure and measured from Maggie to me. Again, we needed to convert, this time from inches to meters.
We then needed to measure the max height to find PEG top and KE bottom for our energy concept. Abby stood halfway from where she was originally standing, and from my same spot, I shot the water at her, and we then measured from the bottom of her feet to the highest point the water hit on her face.
For our fourth and final concept, we figured out the impulse and momentum of the water. We used some of our previous work, such as FW and VI, to figure out our calculations. In this clip, I am taking apart the toy by heating up an X-Acto knife with a heat gun and cutting around its seam.
What we learned from disassembling the gun is that on the inside there is a thin straw-like tube that sucks up the water in the gun when you pull the trigger.
In order to repair the gun, I started by supergluing the two halves of the gun together. Next, I sealed the seam and gaps of the gun with epoxy, which is a waterproof plastic adhesive. As you can see, the gun was able to work after being taken apart and reassembled.
Finally, we are going to talk about how the toy and its concepts relate to real-world concepts. We decided to compare it to a real gun and bullet because the bullet and water both have some of the same theories, such as an acceleration, initial and final velocity, distance, and height.
That concludes our toy analysis video. Thanks for watching.